All right, we want to talk, continue static electricity, talking about how do you move charges through a process called polarization. Polarization is temporary charge movement, not permanent charge movement. All right, so how do you make it happen? Well, polarization happens when a charged object is brought near a neutral object without touching. The electrons in the neutral object will temporarily move. They'll either be attracted or repelled. And how much the electrons move depends on the type of material. So in an insulator, they'll move less. In a conductor, they'll move more. The electrons in the neutral object will spread back out once the outside object goes away. So let's look at an example. Right here we see a simplified electrically neutral metal sphere. It has 5 protons and 5 electrons because positives and negatives, it has 5 protons and 5 electrons. Now, we're going to bring a negatively charged object near, but not touching the metal sphere. It has the 5 protons and 5 electrons in it. What's going to happen? Well, negatives and negatives, like charges, repel. So the 5 negative charges inside of the metal sphere are going to try to move away from the negative rod that is brought near them. So in this case, the electrons move away. The metal sphere is still electrically neutral. There's still 5 protons and 5 electrons, but it's polarized on one side. It's like you've created a temporary charge on one side of this metal sphere. And if you move this metal rod away, the electrons, the red electrons here, are going to spread back out like they normally were. Now we have our metal sphere again, and let's bring a positively charged object near it. Well, remember, protons don't move, so the protons inside of this metal sphere are going to stay where they were. The electrons move. So if I bring a positive charge here, well, negative electrons are attracted to that positive. So you see that the 5 electrons in here move towards the positive rod that's coming near it. And that creates, again, a polarized effect on this metal sphere, where one side is more negative and one side is more positive, but it's still electrically neutral because there's an equal number of protons and neutrons.